Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video we will be doing checkpoint 5.23. This is coming from section 5.6 and that's the ratio and root test. It's actually a summary of all the tests at this point. So this particular question is asking for the series. This is a series as n goes from 1 to infinity of 2 to the n divided by 3 to the n plus n. Determine which convergence test is best to use and explain why. Alright, so if I run through going backwards, the root test wouldn't be so good to use. Root test, because then we were taking the nth root of 2 to the n over 3 to the n plus n. Now, taking the nth root of 2 to the n over 3 to the n is great, but then you have a sum in the denominator, and that second term is n, so this is not a good test to use. And usually, if the root test is not a good test to use, and the ratio test is probably not either. So the ratio test tells us to take the ratio of 2 to the n over 2 to the n plus 1 over 3 to the n plus 1 plus n plus 1, and then divide by 2 to the n over 3 to the n plus n. Now, taking this is not, taking the limit of this as n goes to infinity looks a little bit more complicated than it seems, because you have this extra n that comes out. And so that's going to be a little bit difficult. And you should try it anyways and see what happens, but I would not use the ratio test. This is not an alternating series test. Not alternating series. So I would not use the alternating series test. And if we keep going backwards, the integral test is probably not an easy integral. And divergence test is going to fail, so integral, divergence test, not easy integral. I mean, it might still be doable, but usually if it's not an easy integral, then we stay away from that. So the other things to do is to use a comparison test. And this might be a good candidate for the comparison test, because I'm looking at the factors that dominate the numerator and the denominator, and those are the exponentials. We have 2 to the n and 3 to the n. That kind of makes the n plus n in the denominator kind of insignificant, so I would probably use a comparison test. Comparison test, and that would be compare with again the leading high order terms, or the terms that would dominate in the numerator and in the denominator. So this is equivalent to 2 over 3 to the nth power, and of course we have to know what happens to the series we're going to compare it to, because if we don't, then that's going to be not useful. So this is a geometric series. 2/3 is less than 1, so we know that this whole thing converges. And if that converges, then this is probably going to converge also. You could do some sort of comparison test. The fact that this is a +1 in the denominator makes this expression smaller than this one, and we know that this converges, so we're kind of squeezing in that. You can also do a limit comparison test. I prefer actually the limit comparison test, because you're just taking a limit of the ratio and stuff, but either one should work. So limit comparison test would also work. And we'll compare it to the same series. This is 2/3 to the nth power, which also it converges. So chances are it's going to converge. So I'm not going to finish this because I'll expect you to be able to do the comparison test or limit comparison test for this particular series, and you can work that out. But that would be what I would choose and that would be the reason why I would choose it. Okay, I hope that helps. Good luck.